Thank you for being here this afternoon. Yesterday, we've been surrounded by promises of what AI is going to deliver to our organizations, to our government, to our society. And my goal is to help you understand what's the promise and what's the reality. There's a lot of hype in this space. And what I want to do is bring the reality to the discussion. First of all, there's no AI without data. The problem is that the decision makers, they're working with this huge hairball of data, and they spend 90% of their time sorting through the data, looking for the outliers, figuring out where the data quality defects are, and so on. They're not actually spending time making decisions. They're spending their time crawling through the hairball of data. So the promise of the automation of decision making is we'll introduce algorithmic applications that will help identify the signal and the noise, figure out what is important for the decision that I want to make. That's very promising. But what's the reality? So there's a guy named Alex Linden from Gartner, who I borrowed this slide from. You may know this framework that Gartner has, the hype cycle. As new technologies get introduced, people want to believe that the technology is going to save their world. They're looking for the silver bullets. As the new technology gets introduced, consultants will say, yes, that is the answer. Vendors wanting to sell stuff, yes, that is the answer. And you will slowly climb, sometimes quickly climb, to the peak of overinflated expectations. The technology will do everything, and it will also bring you coffee in the morning, and it's open source, so it's free. Great, yes. And then what happens? You try it out. You realize, again, the consultants were lying. Again, the vendors were lying. And you crash into what's called the trough of disillusionment. You say, this technology is no good, the consultants are no good, throw them all away. Bad technology, bad consultants. This is more or less where Hadoop is living right now, right? We had all the promises, Hadoop is going to solve all the world's problems. It is now crashed. Does that mean that Hadoop is bad technology? No. It means that your expectations were bad. There is no technology that's going to solve all your problems. So figure out what are the right problems to solve with the technology, and then you rise to what's called the plateau of productivity. You should not be throwing Hadoop out of your data center, but what you should be doing is using it for the right applications, not try to do everything with it. AI has gone like off the ski slope, above the peak of overinflated expectations, which means you're headed to a very large crash into that trough of disillusionment. What I want to do is bring you down from that overhyped peak into a plateau of productivity, hopefully without the painful crash. That's the objective of these 20 minutes that I have with you. So first of all, AI, let's face it, it's a marketing term. It means everything and nothing at the same time. AI is a big umbrella, and I can put lots of things under the umbrella. Everybody's products now have AI in their description. I'm going to focus on the use of artificial intelligence technologies in a narrow domain of decision making, prediction and classification. I'm not talking about robotics, I'm not talking about RPA, I'm not talking about natural language processing. Those are all things that you can put under the AI umbrella. Those are not the topics. Right? Decision making, prediction, classification. We used to call this data mining. Data mining is not cool anymore. We don't use that term. Machine learning is the term. I will tell you that 95% of what people are doing with machine learning is the exact same mathematics that we've been using for data mining for decades. Does that mean that there's nothing interesting there? It's not what it means. Machine learning, the insight is not that we change the mathematics, is that we automated. We automated the learning. So in the old days, the data miner, the word we used before, data scientist, they'd build a model to predict which customers are going to churn in the next 90 days. And the moment they deploy the model, the performance of the model's prediction will go down over time. And then, if you're a good data scientist, you're monitoring, you see that the performance has gone down, you go in there and you tweak the model. You introduce new features, you change the coefficients, and then you bring the performance back up again. And then as soon as you deploy it, it goes back down again. It's like a sawtooth. With machine learning, we automate that process. We keep the performance at the top level without requiring the manual intervention of a data scientist. That's the innovation in machine learning. Okay? Now, what I want to do is now focus more narrowly on the 5%, which we'll refer to as deep learning. So when we talk about AI in the context of prediction decision making, I'm really talking about multi-layered neural networks that allow me to take the input data and do transformations on that data in the hidden layers of the neural network, which allow me to see non-linear relationships between the inputs and the outputs. And when I can introduce this technique, it allows me to deal with data with much higher dimensionality. It allows me to deal with missing, dirty, fuzzy data much more effectively. If you, for example, are trying to detect fraud, the fraudsters will purposely obscure their behavior, not give you the full data, give you lots of noise in the data. And the linear mathematical models are not as good at figuring out what is the fraud behavior versus the non-fraud behavior as the deep learning algorithms are. So you get a benefit in increased predictive capability with deep learning. And I'll give you a specific example for a European bank later on in this talk. So deep learning has lots of applications across lots of different industries. We can, for example, in healthcare, take an X-ray image, and I can do the learning on that image with an appropriate training set, and I can learn how to diagnose pneumonia more effectively than an expert doctor. An expert doctor will get it wrong around 4% of the time, depending on the situation. Deep learning software will get it wrong 2% of the time, twice as good. Now we're going to come back to this point later on because we're not done with that discussion yet. But keep in mind that the software can outperform the human. Now, this requires good training sets. This requires large training sets without bias, because if you are taking all your training sets from a university hospital with a bunch of upper-class white kids, you're going to have a biased training set, because now when you apply that learning to a more diverse population, you're not going to perform as well. So you have to pay a lot of attention to the supply chain of the data used in your training sets. But if you do the right things, and if you go beyond just the supervised learning to continued learning with unsupervised techniques, you will perform better than a human. Now, you may be thinking to yourself, that's great if I want to do image recognition. Lots and lots of examples of AI being used. We heard the last speaker talk about facial recognition and facial identification. We can identify a BMW car when it's going by. We can identify a cat in a YouTube video. If you're not interested in those things, is this still interesting technology? Because most of us, let's face it, we're not working with image data. We're working with boring, record-oriented, transaction types of data. So let's take an example of one of these boring data sets. This is a stream of credit card transactions. Each credit card transaction has a timestamp, has a location of where the credit card transaction was executed. It knows the amount. It knows the merchant category code of the retailer where you're trying to do the transaction. So a jewelry store versus a computer store. I know if the card is present or not. I know if this is an online transaction. I know a lot of stuff. All structured data. And I've got a time series of these transactions. I can take those transactions. They're just bits. The coded values are just bits. We can map those bits into an image construct mathematically, very consistently, algorithmically. And those bits that describe the transaction become pixels in the image, mathematically constructed in a consistent way. Now, I can show you an image of a fraud transaction, and it looks different than the image of a non-fraud transaction. And you looking at this, I think you can see the difference in those two images. You probably couldn't tell me without the labels which one is fraud and which one is not fraud, but you can clearly discern that they're different. The multi-layered neural network will figure out, based on the training sets of lots of transactions that are fraud and lots of transactions that are not fraud with appropriate techniques, and you will be able to classify the stream of record-oriented transactions using libraries of software available in the open source today, virtually without modification of that software, really just a conditioning of the data so that you can use those libraries in an effective way. So we did that at a large financial service organization in Europe. Before they deployed these techniques, they were using a relatively traditional rule-based system, and they're catching only 40% of the fraud. 60% of the fraud was getting by them. But perhaps even worse, for every instance of fraud that they caught, they had 99 false positives. Now, what does that mean? Suppose that you are on your first date, you're trying to impress this woman or man that you're taking out. You go to a very expensive restaurant, not the kind of restaurant you would normally go to. You get the bill, you give the waiter your credit card. The waiter comes back and says, "Sorry, sir, sorry, madame, your card has been denied. The authorization was not granted. It's me. I'm trying to buy this dinner. Yes, I don't normally go to this restaurant, but I am a very unhappy customer right now. You have not impressed my date. You have not impressed me. My net promoter score just went way down. I'm on the phone with your customer support call center yelling at somebody on the other end to okay that transaction. Cost you money to run that call center. These false positives have a huge negative impact on the customer and the cost of doing business. And the situation is getting worse because the fraudsters are getting smarter. There's much more transactional activity with card not present because of e-commerce and other things, which means the algorithms are not as effective using these rule-based systems. So when we replaced the rule-based systems, which you can see as the red dot where the performance was for true positives and false positives, with different types of algorithms. So the blue curve is classic machine learning, linear mathematical models, which, by the way, are still much better than the rule-based systems that most banks are using. But when you take it up to the deep learning, which you see as the green line up top, much better performance than either the rule-based system or the classic machine learning. Great, we're very happy with that. But GDPR came at the end of May last year, and one of the caveats of GDPR is every decision must be explainable. Ah, shit, this is a black box. How do I explain that? If you look at the advanced research going on right now, the area of linear, locally interpretable model explanation and other techniques, you can now explain for each decision, and it has to be done on a per decision basis, why did you make that decision? So I want you not to think about deep learning technology only as doing better predictions. You also need to create transparency in how those decisions are made. And it's much harder with deep learning than it is with traditional linear models. And this technique, these locally interpretable model explanation techniques, this is still research. This is in academia. In order to get past the audit, we downloaded software from GitHub that was posted by a grad student. And believe me, grad student code is not banking code. And we had to do a lot of work to get it to a point where we could pass the audit, which we passed, but it did not come as something you just purchase and download and install. A lot of work to do that. So we're still in early stages. Great, deep learning is wonderful. Let's do more of it. Deep learning is the answer. What's the question? No. The smart club in Silicon Valley, which is where I'm from, if you look at Apple and eBay and Facebook and so on, they don't use deep learning for all the predictions. They use a combination of shallow and deep learning. It doesn't make sense to use a multi-layer neural network to predict with 99.999% probability that 2 + 2 = 4. There's much cheaper math to do that. Now that's a simple example, but in fact there's a lot of prediction, for example, cross-selling products and so on, that the linear mathematical models work just fine. Don't think because we've introduced deep learning that you should lobotomize everything that you knew in the past of how to use linear models and replace it with deep learning. Deep learning is expensive. Deep learning is much more opaque than shallow learning. So use a combination of shallow and deep learning surgically to get the best results, to get the most cost-effective, most transparent, and most predictive results. You're going to use a combination of these techniques. So there's this discussion that happens that says, wow, AI, does that mean that machines can think? Answer is no. I think Alan Turing, a brilliant mathematician from England, asked a much more appropriate question. Can machines do what we as thinking humans can do? And the answer to that is yes, sometimes. So I would suggest to you that decisions that humans make in a small number of seconds, deep learning software, together with traditional shallow learning techniques, will be able to make better, faster, cheaper than humans. If you're driving a car down the road, the decisions you make to put your foot on the brake or change lanes, these decisions are made in 2 seconds or less. Deep learning software will be better, faster, cheaper. Believe me, I taught my 16-year-old nephew how to drive. Humans should not be allowed to drive. He will make the same mistakes that I made when I was 16. I made the same mistakes when I was 16 that my father made when he was 16. Humans have to make the mistakes for themselves. Deep learning software, we make the mistake once, we learn from it, and all the vehicles know, assuming that you've got the right infrastructure in place to push out the rules to the edge, et cetera, et cetera. I mentioned earlier, the doctors have a 4% error rate. The deep learning software has a 2% error rate. If the human and the software works together, the error rate is less than 0.5%. So don't think of artificial intelligence as necessarily the strategy to replace humans. Think of AI as augmented intelligence, not artificial intelligence. I've heard a lot of people at this conference talk about AI for replacing humans. This is a bad strategy. It may be appropriate in some cases, but you need to think about making better decisions, and very often, very, very often, better decisions get made when humans and software are working together, not when software is replacing the humans. To be successful, focus on narrow AI, very narrow, tactical, operational decisions. AI is not going to help you develop a better strategy for your company or your government. It is not good at policy making. Can it help the policymakers or the strategic decision makers make better decisions? Certainly, but do not abdicate strategic thinking of any kind to an AI algorithm anytime soon. A very tactical decision, like changing lanes in a car, or determining if this transaction is fraud or not, these kinds of things are where you're going to be successful using deep learning software. So what do I want you to take out of this discussion? First of all, deep learning algorithms are very hungry for lots of data. You need large training sets, you need diversity in your training sets, and you need to pay a lot of attention to make sure that you're not introducing bias into those training sets so you don't get unintended discrimination in the decisions and predictions that you're making. Deep learning is going to continue to evolve over the next 5 to 8 years very aggressively. Whatever is the right answer today will not be the right answer in 2 years. Back in the early days, SAS was the gold standard. Then nobody cares about SAS, R is the gold standard. Then nobody cares about R, Spark machine learning library, that's the gold standard. Then there was Caffe, nobody cares about Caffe anymore, it's TensorFlow. 2 years from now, it'll be PyTorch. 4 years from now, who knows? Every 2 years, you're going to get a new technology. So you need to build into your way of thinking that, you could wait 8 years for everything to stabilize, then you're out of the game. You have to build into your architecture the ability to extend what you're doing, recognize that you are going to get technical debt, and continue to make progress. This is very research-driven. And remember, deep learning is not the answer to all the problems. Surgical use together with traditional machine learning is going to give you the best results. And by the way, we talk about data scientist is the sexiest job of the 21st century. You've all seen that Harvard Business Review article, right? If you're a data scientist and you're not investing in yourself, you will become obsolete. How many of the so-called data scientists know how to build a generalized linear model? Yes, all of you, of course. How many know how to choose the appropriate topology for the multi-layered neural network for a fraud detection algorithm versus a churn prediction? You need to invest in yourself to keep up to speed. So with that, thank you very much.